Ben müsaade ederseniz Jeff Zweerink ile başlamak istiyorum. Doktor Zweerink, astrofizikçi olan Jeff Zweerink, bilim ve dinin uyumunu kara enerji, kara madde, egzogezegenler ve çoklu evren teorileri konusunda anlatımlarda bulunuyor. Bugüne kadar dünyanın çeşitli yerlerindeki üniversitelerde ve kiliselerde konuşmalar yaptı. RTB katılımından önce STACEE ve VERITAS Gamma Ray teleskopları üzerinde çalıştı ve Solar 2 projesi ve Whipple Collaboration araştırmasında görev aldı. Halen Kaliforniya Üniversitesi UCLA görevine devam ediyor. Kara maddelerin tespiti konusunda çalışmalar yapıyor. Dr. Zweerink'in 30'dan fazla makalesi, Astrophysical Journal, Astroparticle Physics ve Astrobiology gibi birçok hakemli bilimsel dergide yayınları var. Dr. Zweerink konuşmasında bilimsel gerçeklerin, evrenin aynı kutsal kitaplarda yer aldığı gibi bir başlangıcı olduğunu gösterdiğini anlatacak. Ayrıca evrendeki kusursuz düzenin ve fizik kanunlarının yüce bir yaratıcının varlığını açık ve kesin olarak gösterdiğini delillerini bizimle paylaşacak. Ben umuyorum ki Dr. Zweerink sadece İncil'den değil, Kur'an'dan da bize örnekler verecektir. Teşekkür ediyorum. Floor is yours.
Well, it's good to be here today. Listen to a lot of cosmologists talk, and there's a very prominent cosmologist, atheist cosmologist named Lawrence Krauss, and he's fond of making statements like this. It says, the amazing thing is that every atom in your body came from a star that exploded. And the atoms in your left hand probably came from a different star than in your right hand. It is really the most poetic thing I know about physics. You are all stardust. You couldn't be here if stars hadn't exploded because the elements, the carbon, nitrogen, oxygen, iron, all the things that matter for evolution, weren't created at the beginning of time. They were created in the nuclear furnaces of stars. And the only way they could get into your body is if those stars were kind enough to explode. So forget Jesus. The stars died so you could be here today. Now, obviously, Lawrence Krauss's statements are specifically antagonizing Christians. But I think his statements are actually offensive to all forms of religion that with a theistic worldview, those that argue for a God who created the universe and all that it contains. Essentially, Krauss argues that science can explain everything and therefore we don't need a God. As a Christian who is a scientist, I actually find a different conclusion. A theistic worldview provides the best explanation of all our scientific understanding of the universe. Let me say that again. A theistic worldview provides the best explanation of our scientific understanding of the universe. So let me share three of the most powerful examples that support my conclusion. Now, at the start of the 1900s, scientists had an understanding of the universe characterized by three significant features. First, the universe was eternal and had existed forever. Second, the universe was static and unchanging on the largest scales. That doesn't mean that planets didn't orbit around stars, but when you got out to big enough scales, the universe wasn't changing. And third, as one moved through the universe, the laws of physics changed in subtle ways. Now, before describing how scientific advances through the 20th century have changed this picture, I want to contrast this early scientific view with the universe described by Scripture. Starting in the very first book, we see that God created the heavens and the earth. In this description, God brought the universe into existence out of nothing. You know, and in Genesis 1:1 there, in the beginning, God created the heavens and the earth. That word for created is to bring into existence out of nothing. This isn't that the universe existed and it was refashioned, that God brought it completely into existence from nothing that existed before. And this is a an aspect that is very definitive about God being the creator, the fashioner, what brought everything into existence. If you look other places throughout the Bible specifically, the prophet Isaiah talks about how I am the Lord, the maker of all things, stretching out the heavens by myself. And not only does this affirm this idea that God is the creator of all things, but it has this idea that the universe is also dynamic, that it's being stretched out, or that it's being expanded, if you will. And if you go look at other prophets, the prophet Jeremiah talks about the universe this way. It says, "Thus says the Lord, if my covenant for day and night stand not, and the fixed patterns of the heavens I have not established." It then goes on to say, if that's true, if those fixed patterns aren't constant, and the patterns of heaven and night are not constant, then he's going to break his promises. And so God's reliability is likened to how reliably the creation operates. And so you see this big contrast between the universe described through the prophets and the Torah and the scientific understanding. The scientific understanding, the universe was eternal. The theistic understanding is that the universe was created and it had a beginning. The universe was static and unchanging, but in the religious books, the universe is dynamic on the largest scales. And in the scientific view, the laws of physics changed as you move throughout the universe. And yet the theistic worldview talks about how the laws of physics were constant, that the fixed patterns of day and night. Well, what is it that governs how day and night happen in the fixed patterns of the heavens? That's nothing other than the laws of physics. And so at the start of the 20th century, science thought the universe was eternal, static and unchanging, and governed by constant laws. And yet God had revealed a universe that began to exist, was dynamic, and governed by constant laws of physics. So let's take a look at some of the important discoveries throughout the 20th century. Well, during the early 1900s, Albert Einstein recognized this scientific description of the day and that the laws of physics changed as you move throughout the universe. And philosophically, he didn't like the idea. So he set about developing a model of the universe where the laws of physics were constant. In doing so, he developed his theory of special relativity and theory of general relativity. And the key feature of these theories is that the laws of physics are constant, regardless of how you're moving or where you're located in the universe. Now, I can tell you this, throughout the 20th century, scientists have thrown numerous experimental tests at the theory of general relativity to see if it's true or not. And it has passed every one of those tests with flying colors. It is one of the best established and best accepted scientific theories known today. One of the consequences of the theory of general relativity is that when you solve the equations, the universe ought to be dynamic, either expanding or contracting. Initially, Einstein didn't like this idea, but measurements in the 1920s and 1930s showed that the universe is indeed expanding. Edwin Hubble, looking out at these fuzzy blobs, they were called island universes at the time, we now call them galaxies, found that these galaxies behaved in a very peculiar fashion. The farther away a galaxy was, the faster it was moving away from us. This is a telltale signature of an expanding universe. And so general relativity predicted a dynamic or expanding universe, and the measurements of these distant galaxies showed that the universe was expanding. And if it's expanding, perhaps if you run time backwards, there was a beginning. Now, scientists resisted this idea for quite some time. In fact, they still resist it today. And they look for numerous ways to have an eternal universe, one that had existed forever. But in the 1960s, with the measurement of the cosmic microwave background radiation, Stephen Hawking and Roger Penrose and other scientists were able to show or develop some very powerful theorems. And these theorems showed that if general relativity is true and accurately describes the dynamics of the universe, and it's passed every test we've thrown at it, so all scientists believe this is the case, and if the universe contains mass, and we're pretty much a guarantee that that is correct, then you can draw the conclusion that when you run time backwards, the universe has a boundary. Now, stated another way, the universe began to exist. So in spite of the scientific view at the beginning of the universe looking very different from a theistic worldview, significant and important discoveries throughout the 20th century have demonstrated that we live in a universe that began to exist. The universe is expanding, and the universe is governed by constant laws of physics. These three features are essential features of all Big Bang models. So what we see is that, in other words, the universe that God revealed to us through the holy books matches the universe we see when we study creation. Now, in recent years, scientists have proposed multiverse models, where our universe is one of a great ensemble of universes. And this seems to challenge the notion of a beginning. In fact, the first time I encountered this idea of a multiverse, that was the challenge this guy was saying, is that if our universe may have had a beginning, but if the multiverse exists, does that really have a beginning or not? But I've spent a lot of time studying the multiverse, and what I know is this, is that even if an inflationary multiverse exists, it still affirms the conclusion that the universe began to exist. Even the multiverse has a beginning. Now, this first piece of scientific evidence that we live in a Big Bang universe that began to exist, that is expanding and is governed by constant laws of physics, this conclusion supports the Kalam cosmological argument. And that argument in syllogism form basically says, whatever begins to exist has a cause. The universe begins to exist, therefore the universe must have a cause. Something outside the universe brought it into existence. Seems very consistent with the idea that there's a God who created the universe. So let's turn to the second piece of evidence. The second piece of evidence that points to the existence of a creator relates to the pervasive evidence of design in the universe. Consider what it takes for humanity to live. I count at least three things. First, you got to have diamonds. No, I'm joking. You don't need diamonds, you need carbon. This was just the best picture of carbon that I could find. You need to have carbon. Second, you need to have water. Water is the liquid that allows all the biochemistry that life requires to take place. And third, you need to have a planet where liquid water could exist in its liquid form with an abundance of carbon. Now, as scientists try and understand how the universe is supportive of life, many come to the conclusion that the universe looks designed to support life. Let me share a couple of quotes by people who are self-professed atheists and agnostics. These are not people, religious people who are looking for God, but this is what they have to say. Fred Hoyle stated, "A common sense interpretation of the facts suggests that a super intellect has monkeyed with physics as well as with chemistry and biology. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question." Roger Penrose, colleague of Stephen Hawking, says, "I would say the universe has a purpose. It's not there just somehow by chance. I can say this, it is uncontroversial to state that the best scientific evidence indicates that the universe appears designed for life. And we see evidence for that design across the scientific disciplines." Let's take a look at some of those areas where the universe looks designed to support life. We live in a universe with three large spatial dimensions and one time dimension. But we can analyze what would happen if the universe were different, if it had two, one spatial dimensions, 3 or 4, 5 spatial dimensions, multiple time dimensions. We can ask that question. So what happens if there were only 2 spatial dimensions? As it turns out, if there were 2 or less spatial dimensions, the universe is not complicated enough for life. Imagine an animal in 2 dimensions. If the animal has a passage for food intake and a different passage to expel the waste, in 2 dimensions, such passages would cut the animal in half. Now, you might say, well, maybe the food could come back out the same way. But it misses the key point. In 2 dimensions, there's not enough connections to be made for the complexity that life requires. It's not just about whether the food has to come out the same way it came in. It's actually far more fundamental. So perhaps if 1 or 2 dimensions is too simple, maybe if we add more spatial dimensions, that's better. That adds the complexity. And it turns out that that's not correct. That if you go to 4 or 5 or more dimensions, it turns out that there are no stable orbits. Now this means 2 things. With more spatial dimensions, atoms are not stable. So the carbon and the nitrogen and the oxygen that life requires wouldn't exist. And planets are not stable. They cannot form stable orbits around stars. They either spiral very rapidly into the star or they spiral away from the star. And so you miss 2 of the key requirements for life if you have more than 3 spatial dimensions. You don't have the atoms that life requires, and you don't have the planets that life requires. Changing the number of time dimensions, that makes things even worse. Now, so if you look at this diagram here, just as you change the number of time dimensions, you get into a lot of these places where physics is unpredictable. Now, you may say, well, I don't know how to do physics. Why is it necessary for it to be predictable? Again, it turns out to be a more foundational principle than that. Because if physics isn't predictable, what that means is that measurements of what goes on right now tell you nothing about what's happened in the past and give you no insight as to what will go on in the future. So organisms that sense the environment and say there's food there and there's danger there, if physics is unpredictable, that's impossible. And so again, the key features that life requires do not exist in any kind of universe except for a universe with 3 large spatial dimensions and 1 time dimension. So now let's turn our attention to the laws of physics. Particularly, let's look at how carbon, oxygen, and nitrogen exist in the universe. To do that, we got to look a little bit about how the universe has developed over time. So in Big Bang cosmology, after the first few minutes, the only elements that exist in the universe are hydrogen and helium. There's small amounts of lithium and beryllium, but for all intents and purposes, we can ignore that. All the elements heavier than this, carbon, nitrogen, oxygen, those are formed in the hearts of stars. So Lawrence Krauss is very much right. The carbon, the nitrogen, and oxygen in our bodies is the dust left over from stars. So we are made up of stardust. But as scientists have studied how well stars produced the carbon and the oxygen, they found huge deficiencies in how much they expected to be produced and how much was necessary for life to exist. Unless some remarkable coincidences were true. In particular, the difficulty of producing carbon is that 3 helium nuclei have to come together to make carbon. So carbon has 6 protons and 6 neutrons. Each helium has 2 protons and 2 neutrons. To get helium to come together to form carbon, you have to have 3 of them come together at the same time. And because it's 3 of them coming together at the same time, that's an incredibly slow reaction. However, as scientists look more closely, they recognize 2 important factors that allowed the formation of carbon. First, when 2 helium atoms come together, they can actually form a beryllium-8 nucleus. It's just 2 of them stick together. Now, that beryllium-8 nucleus is not actually stable. So it doesn't stick around for a long time, but it does stick around for a while. What that means is that in order for carbon to be made, now another carbon just has to come and hit that beryllium nucleus. That's a 2-body reaction. That proceeds much more rapidly. So in order to form carbon, this beryllium-8 nucleus speeds up the reaction considerably. However, even with this metastable beryllium-8 nucleus, stars would not produce enough carbon. Something else was missing. And so one scientist working on the problem recognized a solution that would produce carbon rapidly enough. If carbon had a particular energy level just above its ground state, so if this is its ground state, it had an energy level just a little bit higher, then the reaction would proceed much more rapidly. Now, this energy level was unknown at the time. But scientists have subsequently studied this prediction made by Fred Hoyle and found that, lo and behold, it indeed existed. And so without this stable beryllium-8 nucleus and a finely tuned energy level for carbon, the universe would produce insufficient carbon. Yet in order for the universe to contain sufficient carbon, one more coincidence was necessary. So if you take carbon and add one more helium nucleus to it, it'll make oxygen. If oxygen had this same kind of energy state where here's oxygen in its ground state and there's this energy level right above, then all of the carbon would have been converted into oxygen. And again, you end up with a universe with no carbon. And it turns out that the oxygen energy level was just below its ground state. And so therefore it doesn't exist. And so what you end up with is three coincidences. The beryllium-8 is just stable enough. It's not stable for a long time. That would have used up all the helium. But it's stable enough that another helium can come in. And carbon has just the right energy level so that that reaction proceeds rapidly. And oxygen doesn't have that level, so it doesn't proceed very rapidly at all. And all three of those put together, those amazing coincidences, allow a universe with lots of carbon and oxygen in it. In fact, Fred Hoyle was the scientist who did a lot of the work discovering this. And his quote that I put up earlier about how a super intellect has monkeyed with physics as well as with chemistry and biology was in response to recognizing these three amazing coincidences. Now, I've used the term coincidences, but I really think that the universe is designed to produce the carbon and oxygen that life requires. So let's turn our attention to so similar design features also enable the universe to have the necessary hydrogen for life. And again, to consider what happens in the early moments of the universe. There's only hydrogen and helium. But in those first few moments, the universe is hot enough that hydrogen can come together and make helium. And it just adds one more proton or neutron, and eventually it builds it up. And it turns out that hydrogen has one proton. There's a form of hydrogen with one proton and one neutron or three neutrons. You can have a couple of different forms of helium that have up to four, two protons and two neutrons. And it turns out that there is not an atom that has five, where you add protons and neutrons and get to five. Because if there were, in those earliest moments of the universe, all of the helium or all of the hydrogen would have been fused into these heavier elements. In fact, there's not a 5-nucleon element, and there's not an 8-nucleon element. And because of that, most of the hydrogen is left in the universe. It's 75% of the atoms in the universe are hydrogen. If there was a 5-nucleon atom or an 8-nucleon atom, all of the hydrogen would have been fused into something else. And with no hydrogen, you get no water. So if we take a look at how the strong nuclear interaction, that's what determines how protons and neutrons join together, and the electromagnetic, that's what determines how charges interact, you can make a diagram. And don't get hung up in all the details of the diagram. I just want you to notice this, that if you ask the question, where do all the conditions necessary for life to exist in the universe, where are they all met? It turns out if you're down here, carbon is unstable. Clearly, that's not sufficient for life. Up here, you only have atoms that move close to the speed of light. Clearly not conducive to life. Up here, all of the protons would be joined together and you would have no hydrogen left. It turns out that when you do all of the calculations, the only place where all the conditions for life is met are this little teeny tiny region. Of all the different ways we could envision the laws of physics being put together, only a small range allows the elements that life requires. And so this really looks like we live in a universe that is designed to support life. And this points to design and that there is a creator who fashioned the universe for a purpose. So let's look a little closer to home. We see evidence of design in the moon that orbits the Earth. Not only is it just pretty to look at the night, but it actually is important. Now, Jupiter and Saturn both have satellites that are larger than Earth's moon, but when compared to the size of its host planet, Earth's moon is in a class by itself. The large size of the moon plays an important role in Earth's capacity to support life. The moon stabilizes the rotation axis. Earth rotates around an axis. And the moon stabilizes that rotation axis so it doesn't flip around. Without such a large moon, the Earth's rotation axis would wobble, and that would cause catastrophic and violent changes to the Earth's climate. The moon prevents this wobble, and the Earth has maintained a climate conducive to life for billions of years. Perhaps more importantly, the size of the moon also provides the critical heat that enables the planet to have tectonic activity. You know, we think of earthquakes and volcanoes as bad, but they're just evidence of this tectonic activity that is crucial for regulating the climate of the Earth, as well as building the continents where the bulk of life live. And the gravitational tug of the sun and the moon and the Earth heats up Earth's interior, causing it to flex and stretch and compress, and this heat drives the plate tectonics on Earth's surface. As scientists seek to understand how the Earth acquired such a large moon, they recognize that it took a remarkable collision early in Earth's history. This collision needed to happen at just the right speed, at just the right time, at just the right angle, and with just the right sized object. It really is an unusual collision. The moon looks designed so that Earth can support life, and it also looks like the Earth is just the right size so that tectonic activity is not too large or too small. If it were larger, the plates would be too thick and the tectonic activity would be too small. If it were any smaller, the plates would be much thinner and the tectonic activity would be too great. We live on a planet with just the right size so that the tectonic activity is just right. I want to mention one more piece of evidence for design that we look at when we look at, or that we see when we look inside the cell. When we study the genetic code, we see that it's made up of 4 compounds represented by the letters U, C, A, and G. And I'm not going to go into all the details of that. I'm going to look at it from a computer programming standpoint. So these letters come in groups of 3 that specify the production of amino acids. The sequences of 3 letters where each letter has 4 options means that there are 64 different possibilities. So 4 times 4 times 4. But there are only 20 different amino acids involved in life. So this means that different combinations of 3 will produce the same amino acids. You know, and so if you look here, there's different combinations, and you can have 2 different ones produce phenylalanine, and there's leucine, and you can see that there's some redundancy there. Different combinations of letters still produce the same amino acid. So scientists, go on further, the amino acid sequences determines how proteins will fold. And sometimes different amino acids will still produce the same protein folding. And so that's really kind of the big thing, is do we get the right protein folding? And so scientists can then ask the question, how well does this genetic code ensure that proteins fold properly and function properly, even with mutations in the specific letters? Because we live in an environment where mutations are going to happen. And so given that mutations are going to happen, how well does this code do what it's supposed to do? Well, 2 minutes? 3? All right. The short answer is this. Our genetic code is 1 in a million. If you ask how many different ways could you produce a genetic code that corrects errors, this is 1 in a million in its ability to correct errors. Not only that, it can carry multiple layers of code as well. And I know from a computer programming standpoint, error correcting in a code is incredibly important, especially when you're carrying multiple lines of code. That's very sophisticated programming. And that looks like it's designed. You know, so I'm just kind of reminded of Francis Crick's statement. Biologists must constantly keep in mind that what they see was not designed, but rather evolved. I guess I disagree. When scientists look at the universe, they see evidence of fine-tuning and design. They see fine-tuning in the fabric of space. They see in the form of the strength of the laws of physics and the size of the moon, the genetic code, and many of the others I've not mentioned. It seems to me more reasonable to conclude that where we see design, a designer exists, and that that designer created the universe to support humanity. Now, third point is that the laws of, when you look at the requirements for science, there are philosophical assumptions you have to make. And you have to ask the question, what worldview anchors all of those assumptions? And I'm just going to go through them rapidly. But the bottom line is going to be this. As I have looked at the Christian faith, I know that it anchors all of these presuppositions that you have to do for doing science. And so anybody who wants to say, oh, science supports my worldview has to ask the question, does your worldview anchor all the necessary presuppositions for science? The laws of physics must be uniform throughout the physical universe. The physical universe is a distinct, objective reality, not something that's just an illusion. The laws of nature exhibit order, patterns, and regularity. I think of Greek mythology where Zeus gets upset and throws lightning bolts. That's not real conducive to science developing. The physical universe must be intelligible. The world is an object of rational study because it's not divine and therefore an object of worship. The world is good and valuable and worthy of study. I remember reading about Siddhartha Gautama and how genuine enlightenment came from being detached from the world. Well, if you want to be detached from the world, why would you want to study it and figure out how it works? You know, the free agency of a creator necessitates empirical methods, that God could have done things different, and so we have to measure what he actually did. God encourages, in fact, tells us to take dominion over the natural world. That encourages and propels science. Intellectual virtues essential to science are part of God's moral law. Perhaps most important is that humans possess an ability to discover the universe's intelligibility. I ask the question, does this make sense if atheism is true? I'm reminded of a quote by C.S. Lewis that I think summarizes it well. It says, if the solar system was brought about by an accidental collision, then the appearance of organisms, organic life on this planet was also an accident. And the whole evolution of man was an accident too. If so, then all our present thoughts are mere accidents, the accidental byproduct of the movement of atoms. And this holds for the thoughts of the materialists and astronomers as well as for anyone else's. But if their thoughts, i.e. of materialism and astronomy, are merely accidental byproducts, why should we believe them to be true? I see no reason for believing that one accident should be able to give me a correct account of all the other accidents. If my brain is just an accident, why should it be able to describe the rest of the universe? Given these assumptions or philosophical presuppositions of the scientific enterprise, one should ask the question, what worldviews properly anchor these philosophical presuppositions? A theistic worldview where God creates humanity with a purpose and a moral code and a desire to worship and know God, that does anchor all those assumptions. I'm not saying that a scientist must be a theist to do science, but I am saying that a scientist must adopt a worldview of a theistic for the scientific enterprise to progress consistently and endure over time. So, we live in a universe where the scientific description matches that revealed by God. We live in a universe that's designed to support life, and we live in a universe where a theistic worldview anchors all the presuppositions of science. To me, that says the latest scientific evidence, or our scientific understanding of the universe, is best described or best accounted for by a theistic worldview, and that points to a God who created everything. Thank you very much.